Now let us see how we can use the autocorrelation coefficient and the partial autocorrelation coefficient to find models for data that does not correspond to a plant which is just a moving average or just an autoregressive model. I have here a transfer function with 2 zeros and 5 poles. This is the transfer function. How many parameters does this transfer function have? The numerator polynomial has 3 parameters. The denominator polynomial has 6. Well, 6 plus 3 gives 9, but in fact I only need 8 parameters because, of course, I can multiply or divide both numerator and denominator by a constant and still keep the same transfer function. So 8 parameters is what I need to model the data which I will find in this way. We will suppose, of course, that we do not know the structure of the model. So we will use the autocorrelation coefficient to see how many parameters we need with the moving average, and the partial autocorrelation coefficient to see how many parameters are needed with an autoregressive model. Here we have the results. A moving average model would need a really huge number of parameters. It would be a model with a very high order to model this data. Now let us take a look at the partial autocorrelation function. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would need an autoregressive model of order 10 to model this data. Now, we might try a model with both zeros and poles. In that case, it is reasonable to expect that if the model is to be better, the total number of parameters should be, at most, the lowest of these two values. Well, this one is clearly above 25. I don't even know how far I would have to go until these values would reach these limits within which we may assume that they are 0. Here we have 10. So if I could find a model with at most 10 parameters, or better still, less than 10 parameters, that equally models the data and has both zeros and poles, then that model would be a good idea. Of course, I would in the end have to check this, using, for instance, the Akaike or the Bayesian information criteria, which take into account not only the error between the modeled output and the actual output, but also the number of parameters in the model to compare the different models with different numbers of parameters